Hello students, this question is asked in 2023 14th May shift 2. So he gave a circuit and he is asking in a given circuit the equivalent resistance between A and B is. Okay. Now this is the circuit. Now to find the equivalent resistance between A and B, let us use potential method. Right? Potential method. Okay. So what is potential method? If any device is not present between two junctions, then the potential will be same at the two junctions. So now first let us identify the junctions. This one, here this one. We are identifying the junctions, right? First, here to here there is no device, so the same potential VA, here also VA. Now here to here also no device, so this also become the point A, right? But here to here a device is present, so it cannot become A. Okay. Now next, here to here also a device is present, it also cannot become A. Here to here also a device is present in between, so it cannot become A, right? Now leave it. Now next let us come to B. Now here to here no device, so this is B. Here to here also no device, this is B. But here to here there is a device, so this cannot become B. Okay. So now for that what we will do? We will take a new name for this junction. Let it be some X. Okay. Now here to here no device, this is also X. Here to here no device, this is also X. Here to here also no device, this is also X. Right. Now here to here device is present. Right. So we cannot give X. So we have to take some other new name for this junction as some Y. Okay, I am giving the new name as a Y. Right? So now let us redraw this circuit. So for that, take points A, B opposite to each other. Now next, X, Y. Right? Now let us see what are present between A and X. This is A, this is X. 5 ohm resistance is there. Just draw it. How much ohms? 5 ohm resistance. Again any AX is present? No. This is AY. This is now here to here also becomes Y. This is point Y. No device is there. So this also becomes point Y itself only. Now between A and Y 10 ohms is there. Let us draw between A and Y 10 ohms. Here also between A and Y 10 ohms is present. So let us draw, right, 10 ohms, right? Okay, up to here clear? Now next between Y and B 3 ohms is there. Between Y and B 3 ohms is there. Any more Y and B is there? No. Between Y and B 3 ohms is there. Now next between Y and X. Between Y and X 8 ohms is there. Just between Y and X 8 ohms you just draw. Now next what to see? Between B and X 6 ohms is present. Just draw it. Okay. And here also between B and X another 6 ohms is there. Right? Just we drawed it. Now see the circuit. Now this parallel connection. Here also we are finding parallel connection. Right? Now this is parallel combination. Right? For parallel combination 1 by R equal to 1 by R1 plus 1 by R2. So 1 by R equal to 1 by 10 plus 1 by 10. 1 by R equal to 2 by 10. That is equal to 1 by 5. So R will be equal to 5 ohms. Right? Now here also you see, this is also the parallel combination. So parallel combination. So 1 by R is equal to 1 by R1 plus 1 by R2. That is equal to 1 by 6 plus 1 by 6. That is equal to 2 by 6. That is equal to 1 by 3, 1 by R. So R equal to 3 ohms. Right? Now again let us redraw the diagram. Okay, let us again redraw the diagram. So now here put the points A, B, X, Y. Between X and Y, 8 ohms is present. Between Y and B, 3 ohms is present. Okay. Now between A and Y, 5 ohms. See, between A and Y, 5 ohms. Now between A and X, again 5 ohms. Now between X and B, we got 3 ohms. Between X and B, we got 3 ohms. Now how you are looking this? It is looking like Wheatstone bridge, no? Yes, this is looking like Wheatstone bridge. When we see Wheatstone bridge, immediately we have to see whether the bridge is balanced or not. So let us see what is the formula P by Q equal to R by S. 5 by 3 is equal to 5 by 3. So bridge is balanced. Now here bridge is balanced. So when bridge is balanced, this value becomes 0. When bridge is balanced, this value becomes 0. So now again let us draw by making this as 0. So what you will get? Let us draw here. A, B, X, Y. Bridge is balanced, so we will not have this value. Now between A and X, we are having 5 ohms. Between A and Y, we are having 5 ohms. Between Y and B, we are having 3 ohms. Between X and B, we are having 3 ohms. Right? I drawed this only. This becomes 0 because bridge is balanced. Right? So now, okay, now see, these are in series connection. End to end means, just remember this is series connection, end to end. The second terminal of the first resistor will be connected to the first terminal of second resistor in such a way. The second terminal of first resistor will be connected to the first terminal of second resistor. This we call series combination. So these are in series. Now let us write. So R is equal to R1 plus R2. For upper part I am writing. That is 5 plus 3, 8 ohms. Right? Now for lower part I am writing these two. R1 plus R2. That is equal to 5 plus 3. That is equal to 8 ohms. Now let us draw the diagram. Now this is due to these both. The effective resistance due to 5 and 3 ohms in upper part, 8 ohm. And this is the effective resistance due to 5 ohm, 3 ohm in lower part. Okay, 8 ohm. Right, this is A, this is B. Now how this is? Parallel combination. So 1 by R equal to 1 by R1 plus 1 by R2, right? That is equal to 1 by 8 plus 1 by 8. That is equal to 2 by 8. That is equal to 1 by 4. Khatam khel khatam. R is equal to 4 ohms is the required answer. If you like my video, just share it, subscribe it. Thank you.